three-dimensional problems, some methods may include visualizing and drawing relevant parts of the problem as a two-dimensional problem. So sometimes if it's too tricky to see what's going on three-dimensionally, just take out the part that you're interested in and draw it as a two-dimensional problem. Redrawing the three-dimensional shape as a net could also be helpful. You may not need to do that if you can visualize what is happening in the diagram. So, in bold, this is very important to note, there is often more than one way to solve a 3D problem. Just because I do something some way or the person next to you does it a different way does not mean it is wrong. Often there is multiple ways to get to the same solution. So let's jump into the questions. Number one, we have a rectangular prism there and we want to find the value of theta. Now, because it is a rectangular prism, even though it doesn't look particularly right angle at the moment, this shape on the bottom is a rectangle. Okay, so it would actually be a right angle in there. And the 25 centimetres, we've got that across the bottom here, and we've got 11 on this side, which means this side here would also be 11. That is giving me a right angle triangle. I have got the right angle here, and I've got the two arms. I could use Pythagoras Theorem to find this length here, which is in the triangle that I'm actually trying to find information about to get to that theta. So let's do that. Pythagoras Theorem. The hypotenuse, it's the longest side, is going to be equal to the square root of, do you guys use this formula or do you use the squared one? You happy with this formula? Yeah, you're using this one? Good. So that would be the square root of 11 squared plus 25 squared. Now, something to note when you're doing these questions, knowing that this is not going to be the final answer and you're going to have to use this measurement in a future calculation, be careful how you round things. You either want to leave the answer exact, so you're not going to have any rounding error going through. You want to keep lots of decimal places, or if you're going to write down a rounded answer here, you want to keep the exact answer in your calculator and use that exact answer for the next step. So any one of those three options. So if I do that as a decimal, you will get 27.3 centimetres for this side here. I'm going to write it on, 27.3 centimetres. Okay, there is actually a lot more decimal places to that. So maybe as we're doing this, you could keep that in your calculator so that we can use it, the accurate version for the rest of the question. So I also know in that grey triangle, the 8 centimetres over on the side of that rectangular prism, that would also mean that the 8 centimetres could be put there in the grey triangle. So to find that angle theta, I can use SOHCAHTOA. This angle here would also be the right angle. So it would be the opposite is the 8 and the adjacent, come back. And the adjacent is the 27.3. So let's write down our formula. Tan theta equals opposite over adjacent. Subbing in, tan theta equals, the opposite is 8 and the adjacent is 27.3. Remembering that 27.3, you've got an exact decimal on your calculator. So to get the theta, you are going to have to inverse tan 8 over, use the answer button to keep the exact decimal in. Do you want to try that? Type it in. What do you get? 16.33. Let's do it to the nearest minute. So press the bubble button. 16.20. Yes, good. 16 degrees and 20, and that's been rounded to the nearest minute. Okay, let's do one a little bit trickier. Question 2. All right, it says up here that in this diagram, we want to find angle ABC. Now, carefully trying to draw where that is. A down to B and across to C. That is the theta in there that I'm trying to find. Angle ABC. Now, I probably should have drawn my line a little bit better. Let me redraw that bottom line because it should go through that dot. That should touch it. Okay, because if you have a square-based pyramid, the apex will always be over the center of the square that is the base. Okay? All right, so the 9 that I have in that pyramid, the perpendicular height, that is going to be useful in the triangle that I have here. So this triangle is what I need to use, what I'm talking about. That would be a right angle in there, and I've got the 9. So I need another side though. And looking at that, I've got the 6 millimeter, on that square and the base. So I could probably use that to help me find the diagonal of that square. Yeah? So back to the orange triangle that I had. If I have this whole side here, if this is 6 and this is 6, I can use Pythagoras Theorem to find that whole long side there. Okay, the whole bit. I can't just find the blue bit yet. I have to find the whole length of the orange one. So let's call that BC because that's the letters that are on that diagram. BC squared is going to be equal to 6 squared plus 6 squared. Or in other words, you put a big square root sign over that like we did last time. Now that comes out to be 8.5 millimeters as a rounded decimal. Type it in your calculator though and keep it exact because this one, if we use a rounded answer, we're going to get a different result at the end. Now to find just the blue part, I need to give it a label. I'm going to call it X, that part down the bottom there, the blue part of that triangle on the base. That is just going to be half of that 8.5. Did someone actually work out what that 8.5 was exactly? Okay, so now divide it by 2. 4.2. So 4.24 you said? Yeah. So 4.2. Again, keep that exact in your calculator. So now to find the theta, I have got the 9 for the height and the 4.2 for the adjacent, which is the base of that triangle. So I can use tan again. Yeah? Does anyone need me to draw the triangle out on the side or can you visualize what's happening there? You can see it all right? All right. So tan theta is going to be equal to opposite over adjacent. That's the formula. The opposite that I have is 9. The adjacent is 4.2. Keeping that exact, you're going to inverse tan, 9 over, use the answer button to use the exact decimal, not the rounded one, to the nearest minute again. Good. Okay, so I want you to make an effort, please, to make sure you're not rounding those decimals too early, keeping it exact in your calculator, because you will get different answers to the textbook and to me on the tests if you are rounding too early. Okay, next question. Number 3, a motorist driving on level ground looks due north at a tower with an angle of elevation of 12 degrees. After driving a further 3 kilometres in a straight line, the tower is in the direction due west with an angle of 14 degrees. How high is the tower? Okay, first of all, we have to try and draw this. Okay, diagram is essential. So one bit at a time, let's go through it again. A motorist is driving on level ground and he looks due north and he sees a tower. So the tower is not on the road, he's just seeing the tower away in the distance. Okay, so here is him driving due north. Okay, we know north is in that direction. Going up, north. Okay, he looks at the tower. So at the top up here, he's looking ahead and he's going to see somewhere up ahead of him, due north, is a tower. So up here, here's my tower, T. Now I'm drawing that slightly to the left, even though it should be north. Remember, diagrams aren't always perfectly to scale, because I'm going to need to draw this coming back down to here. And if I draw them perfectly on top of each other, I won't be able to see my triangle. Okay, so just sloping it slightly. Even though I know it's due north, I'm just butchering my diagram a little bit so I can see the triangle. Okay, so that angle of elevation as he's driving there, so he is an angle of elevation of 12 degrees. Okay, so then after driving 3 kilometers in a straight line, the tower is now in a direction due west. So remember, he's here. This is him at the beginning here. He was looking due north and he saw the tower. Okay, that was the first part. But the road, he's not driving towards the tower. The road is actually going to have to slope this way. Oh, wobbly. The road is actually going to have to go that way so that he can end up at a point that is looking west to the tower. So he's actually kind of headed a bit towards the east there, or northeast, so that he eventually ends up looking west towards the tower. So that distance was 3 kilometers. I better add that as we go. Oh, because it's not drawing. Oh, why is it there? So he starts here. He looks due north at the tower. This is my tower here. Tower up here that's called T. And the angle of elevation of the tower is 12 degrees. But he's not driving straight to the tower. He's like driving past the road. The tower is over there, looking north. He sees the tower, right? But this is actually the road that he's on. Okay, because it says he keeps driving on his straight road and he ends up at a point where he can now see the tower, which is due west of him now.
Should the horizontal line be higher? With the T?
So this is like the bottom of the tower, and this is the top of the tower. Okay, because it's like the level ground. The level ground is to the base of the tower. He's on the road is level, the base of the tower is level, but we're looking up at an angle of elevation to the top of the tower to see how high it is. Okay? So this is all level ground, this is the elevation to the top of the tower. So he's over here, level ground. He's going to be looking up there at an angle of elevation of 14 degrees. So one more side going in here, and that angle there is 14 degrees. How high is the tower? So I'm going to draw that in a different colour. We want to find that bit there. I'm going to call it H for the height of that tower. I'm going to need to use some other letters to help identify what I'm doing in this question. So I'm going to label A, B, C for that triangle on the base there, and we've got the T for the tower up the top. Okay, this would need to be a right angle in there. Let me redraw that C so it's not in my right angle. Because remember that was, first of all, due north and due west meeting each other. That's going to be at a right angle in there. Okay, so can we find the height of that tower? Well, the only measurement we have got is the 3 kilometers. So we're going to have to use 2 equations to help us find the height of that tower. Something similar to some of the harder questions that I was doing up here on the board yesterday. So first of all, I'm going to use this narrow triangle over here on the side. Good morning. So in that triangle, I've got the 12 degrees. That's the only number I actually have in that triangle. But if I can use this side AC in there, and then when I use this other triangle, the BC, I'll be able to get a relationship between those 3 sides on the bottom there using Pythagoras Theorem. Okay, see where I'm going with this? All right, so let's give it a go. So if I do 10, because it's opposite and adjacent, 10 of 12 in that narrow little triangle there. The opposite is the H, which is what I'm trying to get. And the adjacent, I don't know it as a number, but I'm just going to call it AC, because that's the labels that I gave it. Okay, now let's get the AC by itself because I want to work on that bottom triangle there. So to get the AC, I'm going to do a switch place, which would be h over tan of 12. Let's do a similar thing now. So let's go and let's look at our other triangle over here and do the same thing to get this, the BC and the H. So it will be tan again. Tan of 14 is equal to, the opposite is H and the adjacent is BC. Let's get the BC by itself, which is H over tan 14. Now, as I hinted, we're going to use Pythagoras' theorem. So I'm going to write a little note here. Using Pythagoras theorem. We know that, can't see my diagram very well right now, AC squared plus BC squared is going to equal to the hypotenuse squared, which is 3, or 3 squared is 9. So I've made an equation that relates the AC and the BC that I found, and we can sub those in. So AC was H over tan 12, and I want to square that, which means I have to square the top, and I have to square all of that tan 12. Then I'm going to do the same thing for BC. That was H over tan 14, and I need to square it, so square the top and square the bottom. And that's equal to 9. Okay, the goal is we're trying to find that H. The good news is H is the only variable in that equation now. The bad news is it's not a very nice equation. How on earth am I going to get H by itself when there's 2 of them and they're squared? Well, you need to get a common denominator, and you're going to have to add those 2 fractions together. So to get a common denominator, we times those 2 denominators together. So tan 12 all squared and tan 14 all squared. Now that means I'm going to have to multiply this h squared with tan 14 squared and that h squared with tan 12 squared. Okay? It will get neater again, but it's got to get messier before it gets neater. So tan 14 squared times the h squared plus tan 12 squared h squared. And that's still equal to 9. Now, I know we're running out of room here, but we can go a little bit down the side here. I'm going to do 2 things on this next line. I'm going to factorize the h squared out of the top, so that I now will just be down to 1h in my expression. And I also want to times that denominator across to the other side so I can get rid of the fraction. Okay, so factorizing the h squared out, I get tan 14 squared. Now here's a little, you can put the squared there and it means all of tan 14 squared, plus tan 12 all squared, because I don't want to have too many brackets, which is why I'm doing that kind of notation. And that is equal to 9 times by my denominator coming across, which is tan squared 12 and tan squared 14. The reason they put for this, once I've taken my tan squared like this, and I'm now writing it like this, the reason they put the squared there instead of after the 14 is because otherwise people would square the 14 first and then do tan of whatever 14 squared is. So putting it here means you need to find tan 14 and you need to square the whole thing. Okay, so that's what that notation there means. All right, we're almost there. To get the h squared, I can now divide this bracket, messy as it is, divide that whole bracket underneath. So that means h squared will be by itself. H squared equals 9 tan squared 12 tan squared 14 over tan squared 14 plus tan squared 12. And then you have to type that in your calculator.
What did you just do?
All I did was take this bracket and I'm putting that underneath this, just coming down underneath there. Okay, so grab your calculators out, type in that lovely messy bracket. You will have to put the tan, you can't put that squared in there when you type that in, so everyone should give this a go because it's the first time typing this kind of stuff in. You'll have to type tan 12 in brackets and then the squared on the outside like we did originally. Okay, because otherwise your calculator won't know what to do. Let's see if we can all get the same answer. I'll tell you what I got was 0.23547. That's h squared. And I think there's some more decimal places after that. That was just the first few. Give it a go. Got it? Excellent. Nope. Missed a squared maybe somewhere. Oh, you got a math error? Which means, if you get a math error, it means you possibly haven't closed a bracket somewhere. Oh, syntax error. Check for it. Go use the back arrow and see if you haven't closed a bracket somewhere. You got a different answer? You got all the squares in there? And this one is a plus in between here.
Oh, 4.36.
Yeah.
How do you write the tan squared?
Alright, let me bring up my calculator. So let's go, I'll do a fraction first. 9 times. Right. You got it? Great. Tan of 12, close bracket, squared.
I just have to say. 2, 3, 5, 4, 7.
Yeah, that.
And also keep it down to feel like it's again.
Oh, I did. I missed the first bracket. See, I would have got an error. Go back. I must have missed a bracket. Where did I miss it?
So you're doing the operation from before.
Yeah?
It's 0.4.
Oh, when you square root it, yes.
Yeah, when I read it.
I got 0.17.
Alright, did you guys manage to get it?
Maybe square the end.
I didn't square the end. Was that the button? Oh, is that what the button was? The button. I was going fixing my bracket. Go back.
No, so maybe you were right.
Let's try that. There we go.
Did you?
All those 2's in there. Alright, so that is the h squared. We still need to get the h by itself, which means we need to square root that. So just go square root, answer, don't type it in again, equals. So 0.485. I'm going to do 3 decimal places there. Now, it's not very big because remember that this is the height of the tower and all the other measurements that the only measurement that I've been using is in kilometres. So that measurement is in kilometres. It probably would make more sense to change that into metres, which would be 485 metres.
Would we lose marks if we didn't do it?
No, if I didn't specify, it'd be fine. Okay, there's one more part here to do, and thankfully this one doesn't take up quite as much space. Part B. In what direction is the car travelling? So back up here to our diagram. Remember, our car is started here, and it is travelling over here towards B. So the direction, I need to find that angle. Okay, so I can find the bearing that I've headed off on. So let's call that theta. So in that triangle, I have got Oh, let's see. The H was... Oh, I'm going to have to work out what those sides are. I don't have any other sides yet. So let's work out AC. Because I've only got 3 kilometres at the moment. So using my equation, I'll take this equation here so I can find another side in that triangle. Okay, so let's go. AC equals the H that I just found, and I'm going to use it in kilometres because the measurement in my diagram is in kilometres. Over formula, using the yellow formula, 10, 12. What do we get? Type it in. 2.28. Yeah?
Yeah.
Okay, so I have found, by using that formula, that side there is 2.28. So looking at my theta, I have got the adjacent side now by doing that, and I've got my hypotenuse, so I can use cos. So cos theta is equal to adjacent over hypotenuse, and I'm going to have to inverse cos to get theta by itself. And let's just do this to the nearest degree since we're going to do a bearing. So I got 40 degrees to the nearest degree. So that means the car is... were you keeping the exact answers in your calculator? Or did you round that 2.28? Yeah. So that's what, the whole way through, you always kind of keep the last answer in your calculator so that you don't have the rounding error, because that's probably what it is. The car is travelling on a bearing of 040 degrees T. So that question was quite intense, wasn't it? A lot to that one. So we do have the rest of our double to finish off 6C.